So Megan, this problem works off of the fundamental theorem of calculus. And we know from the fundamental theorem of calculus, I think I gave you that sheet last week when I saw you, that if we have the integral from a to b of some function f, that's going to be equal to, if you have an antiderivative of f, which in this case they're calling capital G, you can take the top boundary, your b value, plug it into capital G, and subtract from that the a value of capital G, and that would actually give you the value of the integral from a to b. So how do we know what numbers to plug in here? Well, they're asking about g of 4, and they've given us g of 2. So I'm thinking that what we should do here is plug in for a 2 for the lower boundary and 4 for the upper boundary here of our function f. And if we integrate that, that would then be the same as taking g of 4 minus g of 2. We obviously can't do the integral there because we don't know f of x, but we don't need to know it to answer this question, because what we can do now is we can just add, we want g of 4, so we can just add g of 2 to both sides. And then that will cancel on this side. And so now what I have is I have an expression that says that g of 2, capital G of 2, plus my integral from 2 to 4 of my function f of x is equal to g of 4. And I actually know what g of 2 is, so I could say negative 7 plus the integral from 2 to 4 of f of x is equal to g of 4. And so based on this work, I would choose E as the correct answer. So we can talk about this again if you have time to see me tomorrow or sometime this week, but that's how I would go about doing this one.